Hi guys, this is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. Today we are going to see the Unit 5 Vector Integration, the last section in this unit, that is Stokes Theorem. So Stokes Theorem here, it's very important, and they will be asking in 10 marks and 5 marks as well as the 2 marks also, depend upon the question. So Stokes Theorem, if S is a surface bounded by a simple closed curve and C, that is a C, closed curve is named as C, and S is a surface, if F vector equal to F1 I vector plus F2 J vector plus F3 K vector, that is not a vector, that is a cap actually, I cap, J cap, K cap, be any continuously differentiable vector point function, then integral over C F vector dot dr vector equal to double integral over S del cross F vector into N cap ds. Okay, so del cross F vector, it's basically we know that it's a curl, and this is grade. So where n cap is a unit normal vector, unit normal to the surface S, that we know very well. So this is a Stokes theorem definition. Now we are going to see the problems in the Stokes theorem. Using Stokes theorem, prove that divergence curl F vector equal to 0 and curl grade phi equal to 0. So two things we are going to see here today. So two subdivisions they are given. See, first curl F we have to find, then divergence of curl F we have to find in the first section, and the second one grade phi we have to find, and then curl grade phi we have to find. Now let us S be the surface enclosed by a simple closed curve. See, that is the by the definition of the Stokes theorem. Now we know that the Stokes theorem, integral over C del phi dot dr vector equal to double integral over S curl grade phi n vector ds. Take this as a first equation. So now we are going to find the del phi, which is equal to called as grade phi. So I vector into dou phi dou x plus j vector into dou phi dou y plus k vector into dou by dou z. This we know already, we have seen in the previous classes. So del phi into dr equal to this vector into dx plus dy plus dz. Okay, so dou by dou x into dx plus dou by dou y into dy plus dou by dou z into dz. So this can be written as total derivative, that is called as d phi. Now integral over C del phi dot dr vector equal to integral over C. Instead of this we are writing d phi, that is a total derivative, which is equal to 0. If you are differentiating, we will get 0 only, because I didn't give anything right now. So since C is a closed curve and hence lower and upper limits are same. So since a closed curve, so upper limit and lower limit will be the same only, because it is a closed curve. Closed curve like that, it's just like a circle. So from 1, so double integral over S curl grade phi n cap ds equal to 0. Therefore, since S is arbitrary, curl grade phi equal to 0. So both the terms, if you are getting 0, then the first term got over. Then for the second one, that is we are going to prove divergence curl F equal to 0. So first case we are going to prove. So please change it as here this one here is a second subdivision, and this one here is a first subdivision. Please change it over there. Let S be a closed surface enclosing a volume B by divergence theorem. So double integral over S curl F vector at n cap ds equal to triple integral over V divergence curl F vector dot dv, because we are considering here as a volume. So by divergence theorem we are using, then by Stokes theorem we know that F vector dot dr equal to curl F vector dot n cap ds. So S is a closed surface, divide S into 2 S1 and S2 by a closed surface C. So then here C is common boundary to the S1 and N2. Okay, so we are dividing the surface into two parts, S1 and S2. So S1 into curl F vector n cap ds, which is equal to C into F dot dr vector, and S2 equal to curl F vector n cap ds equal to minus C into F vector dot dr. Since the positive direction of C is on S1 and opposite C is on S2. So now double integral over F curl F vector n cap ds equal to, so S1 plus S2. So this is F vector, then this is minus F vector dot dr, which is equal to cancelling, and we get 0. So from the 1 implies, so here triple integral over V divergence curl vector dv equal to 0. Therefore divergence curl vector F vector equal to 0. So this proves the first case. Okay, so next problem, verify Stokes theorem. This is an important university question. Verify Stokes theorem for F vector equal to, they have given one function taken around the rectangle bounded by the lines x is equal to plus or minus a, y equal to 0, y equal to b. So these are all the limits. So x is equal to plus or minus a and y equal to 0 b. So y varies from 0 to b, x varies from 0 to plus or minus a. So we have they are having one function that is f vector they have given. We are going to verify the Stokes theorem. Let C be the boundary of the rectangle. Let us take the C here. Usually we will take the C as a curve. Here we are taking the boundary of the rectangle, because in the question they have given the rectangle bounded by the lines. So f vector, the given question is x squared plus y squared plus I vector minus 2xy j vector. Now f dot dr is this one into dx plus dyj. So into dy, so I into I becomes as 1. So x squared plus y squared into dx minus 2x y dy. Now we are drawing the rectangle, that is it is upper on the x axis and y axis. So only the here the first quadrant and second quadrant it's covering. So the curve consists of 4 lines, that is AB, BC, CD and DA. So this is a rectangle. Then this is a point origin O, then the x axis, y axis, and here x is equal to a, x is equal to minus a, y equal to 0 and y lies between 0 to b they have given, and x plus or minus a they have given. So it is a plus and minus quadrant, so minus will come, here plus will come. Now integral over C f vector dot dr equal to AB plus BC plus CD plus D. We are splitting into 4 integrals. Okay. So first we are seeing along AB. Along AB here x is equal to a, so the dx is equal to 0. See, along AB means here x is equal to a, so dx equal to, if we are differentiating, 0. So f dot dr equal to x is equal to a, no, so there you can put 0 minus 2a by dy. So if you are getting the answer as minus 2a by dy. Y varies from 0 to b. Here y varies from 0 to b only. So integral over f dot dr equal to minus 2a into y dy integral over 0 to b. So after integrating we are getting the answer as minus ab squared. Next, along BC we are going to find BC. Here y value is b, so dy equal to 0. So f dot d vector equal to y is c, so just take the remaining thing, instead of y just put b, so b squared will come into dx. Now x varies from a to minus a, so bc into f dot vector equal to a to minus a, and then x squared plus b squared into dx. So after integrating we will get the answer as minus 2 into a cube by 3 plus ab squared. Likewise along CD, x is equal to minus a. CD is CDx is equal to minus a. So dx equal to 0. So 2a dy. So from this also we are getting minus ab squared, b to 0. Values will be differ from, y varies from b to 0. See here y varies from b to 0 here. CD, no, so b to 0. So dA y equal to 0, again this is from minus a to a, and we get the answer minus 4ab square. Now we have to substitute all the values in this term, that is the first equation. This you are going to substitute. So integral over C f dot r vector, f dot dr vector equal to, we will get the answer. So you have to substitute all the values there. So here we have so 4ab plus bc plus cd plus da. So take this as a second equation. Now we are going to evaluate the next side, that is double integral over S curl f vector at n cap ds. It's the left hand side. So curl f, we know that ijk dou by dou x dou by dou y, and then the given question z is term is 0, so you can write it. After determinant you can take it as, so minus 4y into k vector, you will get the answer. So for the rectangle ABCD, n cap equal to k vector. Since the rectangle lies in the xy plane, right, it doesn't cover the z plane, so only it is in the xy plane, so n cap equal to k vector we are choosing. So curl f vector at n cap equal to minus 4y k vector into k vector, that is minus 4y. So in the xy plane ds is equal to dx dy. So double integral over curl f vector at n cap ds equal to r into minus 4y, that is a curl f vector into n cap value is curl vector into n cap, that is minus 4y, into ds is dx dy divided by modulus of n vector dot k vector. So before the Stokes divergence theorem we have seen the formation like this, so that we have introduced here. So double integral over values will be dx dy, so it is in the region R. So what will happen, 0 to b and minus a to a, this is given in the question. X varies from minus to a plus a, and y values will be varies from 0 to b. So after applying, since n vector equal to k vector, n cap equal to k vector, So after integrating this, we are getting the answer minus 4ab square. So minus of 4ab squared. So from 2 and 3, so there also we are getting the minus 4ab squared after resolving this. So both are same. So hence prove the Stokes theorem. Both the sides are equal answers we have got. So Stokes theorem is verified. So this one question is important. They will be asking this question, or in the same method they will be asking some other question. Most probably this question will be asked in every year in the, if they are asking the Stokes theorems as a question. Okay, thank you so much for watching. So unit 5 ends here. So portions completed for the university examination, everything completed. If you have any doubts, please approach me.